Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, instructor for this course in introductory statistics. In less than 10 minutes, this video describes the conventions for hypothesis testing of two population proportions and shows how to do it using StatCrunch. Let's get started. So you're going to see that there's a lot of similarities between hypothesis testing for two population parameters and hypothesis testing for one. So all the things that we've learned from previous mini lectures about hypothesis testing, a lot of that's going to stay exactly the same. One of the big differences is that now that we've got two populations that we're testing, we're comparing the two. So we've got a sample from each of those populations. And to distinguish between the two, we're going to give a subscript 1 to parameters and statistics from one population and sample, and then we're going to give a subscript 2 to the parameters and statistics from the second population and sample. And typically the first sample or population that's mentioned is going to carry the subscript 1. The one that's mentioned second in your problem statement is going to be the one with the subscript 2. Now, we could take each of the two samples and combine them into one. And so this brings us to the concept of what's called a pooled sample proportion. And we represent a pooled sample proportion with P bar. And you can see we're calculating it here by taking the parts for each of the samples that we're looking at, and then we're dividing it by the sum of the sample sizes. Okay, so we've got both parts that we combine together to make one big part, and then we've got both of the wholes that we combine together to make one big whole. So one big part over one big whole, there's your pooled sample proportion. Of course, Q bar is just the complement of P bar. So when we see that in the equation, we know that we're just going to have to subtract P bar from 1 to get Q bar. As always, our methodology makes certain assumptions, and so we need to make sure that those assumptions are met so that we can use our methodology. So our methodology will actually apply. First, we're going to assume that the proportions are from two independent simple random samples. And second, we're going to assume that each of the two samples has at least 5 successes and at least 5 failures. This allows us to use the normal as an approximation to the binomial distribution. As always, our null hypothesis is going to be a statement of equality, so that's not going to change. That equal sign is always going to go with the null hypothesis. But now we've got two populations that we're looking at and not just one. So instead of setting this to some sort of claimed value, we can just set them equal to each other. And this is a typical way to write the null hypothesis when you're looking at two proportions. Sometimes in certain quarters you're going to see an algebraic equivalent of that. It looks different, but it really isn't. To demonstrate that, let's just take the first form that we get, P1 equals P2, and if I subtract P2 from both sides of my equation, what I'm left with is that algebraic equivalent that we see up above. So P1 minus P2 equals 0 is exactly the same as P1 equals P2. Sometimes you'll see it in one way, and sometimes you'll see it the other way. And that's the reason why I'm bringing this up here, because this first way that we're looking at is typically valued by your assignment. So the preferred way of expressing the null hypothesis in your assignments is going to use that first format. However, StatCrunch is going to be using that second format that we're looking at here. So when you're matching your hypotheses up between StatCrunch and your problem statement, keep in mind that it's not going to look exactly the same. You're going to have to think about algebraic equivalence here. And as long as you've got the algebraic equivalent, then you should be good to go. The alternative hypothesis still typically represents the claim unless there's some semblance of equality, in which case we're just going to take the complement, just like we did before. So we could write this with the population parameter on either sides of our inequality sign. Or again, sometimes you'll see the algebraic equivalent, but don't worry about that. It's the same thing. Just recognize that they are the same. And then sometimes when we're forming our hypothesis, we're going to be using a lot of the same conventions that we used for one sample. Again, the only Main difference is you got that subscript 1 and 2 that you're dealing with. To test the claim with the hypothesis test, we have a new test statistic. Of course, since we've got 2 population parameters to look at, so now we've got an expanded form of our test statistic. Okay, much like what we saw with proportions when we're dealing with just 1 sample, but now that we've got 2, we've got to have a portion here representing the second sample. You could do this old school way if you wanted to. I actually prefer to do this in StatCrunch, and I'll talk in a minute about actually using StatCrunch for 2 proportion hypothesis testing. But we calculate the p-value using this test statistic or z-table. We use software. I mean, again, the same methodologies that we used before with the 1 sample, we're going to use again with the 2 sample. Critical values for 2 samples are going to be the same as for 1 sample. So if you know how to do it for 1 sample, you know how to do it for 2 samples. You're just taking a critical value for each sample. And we're going to use the same criteria to test the claim. So if we're inside the region of rejection, we're going to reject the null hypothesis. If we're outside, we fail to reject the null hypothesis. In StatCrunch, the menu options you're going to see are very similar. The main difference you're going to find here is that instead of selecting 1 sample for your problems, you're going to select 2 samples. Okay, so go to Stat, Proportion Stats, 2 sample with summary. Typically, you're not going to have actual data, so you'll just select with summary. In the options window that comes up, you're going to put in your information. Again, remember, typically the first sample is going to be the one that's mentioned first in your problem statement. The one that's mentioned second is going to be sample 2. But the way you put the numbers in is exactly the same. You've just got twice as many to deal with. Keep in mind the algebraic equivalent here in StatCrunch. It's not going to look exactly the same as what you see in your assignments, but it's algebraically equivalent. And typically this default value of 0, you're just going to leave that in there. Leave it as is. That's typically what you're going to see for most of your problems. And then once you get your results out, just go ahead and it's the same as what we saw before. Test statistic, read it right off the results window. Second to last number there in the table. The p-value, as always, the last number listed there in the table. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountAcademy.com. Thanks for watching. We'll see you in the next video.